Hi, we are engineering brothers, and once again we have got our another consideration for our location of our poles and how do we comment regarding that output response over there, or whether the system is stable or unstable, that we are just going to consider over here. In our previous part we have considered the complex conjugate poles over there, and there are only one points, rather two points, or the two poles that are present over there, or only one complex conjugate poles are present over there. Now in this case we are having our infinite number of roots that are considered over here. Now we are having the same plot, but if you say that there are many other poles or the complex conjugate poles that are placed on the same points for this S is equal to this one over there, then what is the considered point, or what is the exact comment on the stability regarding that system over there that we do require to consider over here. Now first of all, we are just by looking at this location of our poles of our S plane, we are having this is going to be our location of our S plane over there, and accordingly, or at the same point of our S points, the poles are located in a repeated basis, and because of that we can say that this is going to be a mathematical expression over here, which is a1 sin omega t plus a2t sin omega t plus dot dot dot. There are lot of number of poles that are associated, lot of number of roots that are present over there, and ak t to the power k minus 1 sin of omega t over there. And this is going to be a solution over here, where the k is the number of the roots over here. Now quite naturally this is going to be our S plot, and after we have analyzed the S plot over here, the mathematical expression will be this one. Now while considering the plotting portion, which is CT versus time factor over there, we have realized that the peak of our plot will be from 0 to A, and the oscillation will be there, but the oscillation is constant throughout our operation over here. That is why we can say that this system is marginally stable. Why? Because the value is not going towards 0, or that is not going towards infinity as well. And you can see that throughout our operation of our waveform, throughout our operation for our CT versus time curve, we have realized that the curve do have the constant oscillations over there. That is why we can say that this system is marginally stable. Now let us just consider for a lower factor over here. We can see that the plotting point will be this one, and at the same point there are a lot of roots that are present over here. Now this is going to be our S plane, that is, you can see that at the same points there are a lot of roots that are present, or a lot of poles that are present over there, or at the same plot over there. Now this is going to be our mathematical expression over here, which is quite naturally a1 sin omega t plus a2t sin omega t plus dot dot dot, and this is going to be our mathematical expressions over here, and k will be our number of roots. Now as you can see that, now let us just plot this CT versus time plot over here, and if you just do plot that over here, we have got this is going to be our nature of our waveform, and you can see that if you just do increase the time, the oscillation is increasing with respect to time, and that actually do give us the unstable characteristic if you just do look at the curve of our CT versus time factor over here. Now how do we say that what is the exact comment for our given consideration over here? Once again we can see that as the plot is placed at the left hand side of our S plane, that is not the only case, but the another factor will be we should consider the CT versus time curve over here. Just by looking at this location of our poles over S plane and the CT versus time, which is the output response of the system. Just by analyzing these two considerations, we can consider or we can comment on the stability of that regarding of that system over there, and quite naturally this will be the nature over here. Now as you can see that the location of our poles are at our left hand side of our S plane, but still the waveform do have the constant oscillatory characteristic over there. That is why we can say that the system is marginally stable. But if you just look at the location of our poles, we should comment that the system do have the characteristic of our stable consideration. Why? Because these poles are placed at our left hand side of our S plane over there. Accordingly, we should consider both these two consideration. The first one is our S plane, and the second one will be quite naturally the CD versus time curve over there. And just by looking at these two characteristics, we can consider that the system is marginally stable. And in our lower part, this one will be quite easier, as you can see that the poles are placed at the right hand side of our S plane over there, and quite naturally if you say that the poles are placed at the right hand side of our S plane, then automatically the system do have the tendency or do have the characteristic to become the unstable systems over there, and that actually gives us the ultimate confirmation over here, which is CD versus time factor over here, and the oscillation is increasing with respect to time over here. That actually do lead us the unstable characteristic over here. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section for better understanding. Do like, do share our videos, and keep following our channel. That's it. Thank you and goodbye. If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.